When we imagine life in orbit, we often picture wide-open, futuristic corridors. But the actual utilitarian reality of modern space travel looks more like a submarine. For decades, small groups of people have lived inside tiny metal boxes filled with exposed wiring and cramped equipment. And despite our technological leaps, the basic requirements for survival remain gritty. Astronauts today still rely on the same fundamental cycle as eco-only pioneers, capturing and recycling every drop of wastewater and sweat to survive. To understand why we are still living in these cramped conditions, we have to look at a specific engineering approach called modular construction. Every major space station, from the Soviet Mir to the International Space Station, was built like a patchwork quilt. They were launched in small pieces and then stitched together in orbit using robotic arms and manual labor by astronauts in spacesuits. This method creates a massive bottleneck. Every room is limited by the diameter of the rocket that carries it. If a module has to fit inside a space shuttle cargo bay or a standard nose cone, the result is a maze of tight corners and physical choke points. NASA actually found a way around this back in 1973. By taking an empty Saturn V rocket stage, originally meant for the moon, they created Skylab. It offered a massive, unsegmented volume where a crew of 3 could cartwheel through open space. We are now seeing a return to this single-launch philosophy with SpaceX's Starship. This vehicle is 50 meters long and 9 meters wide, providing a single internal volume that dwarfs the International Space Station. By choosing to live inside the spent rocket itself, we remove the physical constraints that have limited space architecture for the last 50 years. Once the ship reaches orbit, the transformation begins. Since this vehicle will never return to Earth, the first phase is a robotic demolition of its flight hardware. Autonomous robots will move into the empty fuel tanks to rip out plumbing and install interior floors. This turns the massive storage voids into usable decks while the ship is in zero gravity. On the exterior, these robotic crews will remove the engines and replace them with docking ports for cargo ships. They'll also install the massive solar arrays and cooling radiators required to power a station of this size. Looking at this vertical cross-section, the transformation is clear. The bottom third, the old fuel tanks, becomes the station's basement on decks 10 and 9. This is where the critical systems live. Deck 9 houses the life support systems. Using a chemical reaction called the Sabatier process, the station filters the air to remove CO2 and splits recycled water into fresh oxygen. Every drop of moisture on the station is captured and reused. These water tanks also line the outer hull of the deck. Because water is an effective shield against radiation, this level serves as a reinforced bunker where the crew can retreat during intense solar flares. It is utilitarian and dense, but these lower levels handle the difficult physical realities of survival so that the decks above can focus on human life. As we move up into decks 7 through 4, we enter the habitat zone. This is the part of the station designed specifically for long-term human residence. Deck 6 is the fitness center. Without gravity, human muscles and bones wither away quickly. To prevent this decay, every crew member is required to complete 2 hours of high-intensity exercise every single day. Moving up, Deck 5 provides private crew quarters. In the past, astronauts slept in bags strapped to walls, surrounded by bulky hardware and constant noise. Here, a crew of 20 has actual personal space and dedicated windows. Above that, Deck 4 is a state-of-the-art orbital laboratory. In this microgravity environment, researchers can manufacture new molecules and study biology free from the physical constraints of Earth's gravity. With adequate space for rest and work, the crew can focus on scientific discovery and orbital manufacturing for months at a time. We finally reach the communal space on decks 3 to 1. This area uses an open concept design to maximize the sense of volume at the top of the rocket. This zone is dedicated to the psychological health of the crew. It includes amenities like zero-gravity gardens, virtual reality zones, and communal dining areas. The focal point is the observation deck in the nose cone. Wrapped in massive glass panels, it offers a 360-degree view of the Earth and the cosmos. From this vantage point, the crew watches the sun rise and set every 90 minutes. It provides a constant visual connection to the planet below as the station travels at 28,000 kilometers per hour. These open views provide the psychological relief necessary for long-term missions. The experience of being in space becomes expansive, defined by the panoramic view of the solar system. While this sounds like a vision of the distant future, it is grounded in the current reality of the aerospace industry. SpaceX is already building the infrastructure for thousands of launches. Their roadmap includes deploying massive satellite constellations and eventually establishing a human presence on Mars. Sustaining a city on a distant planet is a massive logistical challenge. By comparison, keeping a single, empty rocket in low Earth orbit and converting it into a station is a much simpler task. A Starship Space Station is a practical application of the hardware we are already building. It is one of the most accessible goals of the next decade. Using these massive vehicles as habitats is a logical progression in our engineering. It provides the physical volume needed for a permanent and productive human presence in orbit.